Over this, I'm going to go over it relatively quickly because it's pretty much the same as the others that we did. We see that we've got the 5 states. Let me make that bigger because we know it's a Moore machine because the output does not depend on the input. And we can see that because the output is assigned outside of the always block. So this is A, B, C, D, E. And our input is W. So if W means if W is 1. So if we're in state A and W is 1, then we go to D. If W is 0, we go to B. If we're in state B and W is 1, we go to D. If we're in state B and W is 0, we go to C. If we're in state C and W is 1, we go to D. D is very popular. If we're in state C and W is 0, we go back to C. If we're in state D and W is 1, we go to E. If we're in state D and W is 0, we go to B. If we're in state E and W is 1, we go back to E. And if we're in state E and W is 0, we go to B. Then the next always block says that, and we have our default. We have to have the default. And the default needs to be a 3-bit binary number. And here it's given to be a don't care. You could have the default. You could say, no, the default is A. You know, I want, if I get an unexpected value, I want it always to go to A. But here it's just a don't care. And then this always block tells us that our reset state is A. So put a reset here at A. And then the else y equals y, that's advances to the next state. And then our output is Z equals, does y equal C or does y equal E? So Z is 1 if y is C or if y is E. Otherwise, Z is 0. Which also illustrates something that you don't always know with different programming languages, that what if, like in some programming languages, if I didn't have an else here, the Z for A, B, and D might be just kind of random numbers, but here we see that it's going to be 0. It's not, you know, if it's not defined, it'll be 0.